This week we will start by correcting our formal homework that was submitted last week. Percentage of air that is made up of oxygen is 21%. Your combustion equation for a fuel or for ethanol would be plus oxygen, and you get carbon dioxide and water. You then had to label the apparatus, and the words were given below. Filling in the table, oxygen, you add hydrogen peroxide to manganese boraxide, or it's sometimes referred to as manganese dioxide. And when you produce hydrogen, you add a metal and an acid together. So in our practical, we used magnesium and hydrochloric acid. The word equation for the preparation of oxygen is the decomposition or the breaking down of hydrogen peroxide, and you get oxygen and water. You don't put the catalyst into the equation. What is the function of the catalyst? A catalyst speeds up a chemical reaction without being used up. One example of a catalyst, you could have put in the catalyst we used to produce oxygen, which was manganese dioxide, or any of the catalysts that were mentioned in the video. The test for oxygen gas is it relights a glowing splint. The uses for hydrogen gas were on the video clip. It's used in rocket fuel, it is a clean fuel, and making margarine. Hydrogen is less dense than air and colourless, and if a lighted splint is placed in a test tube, you get a squeaky pop with hydrogen. Here's a quick quiz that we're going to do in class. Give the formula for hydrogen. Name two chemicals used to make hydrogen. How did we collect hydrogen last week? How do we test for it? Two uses. And when we burn hydrogen, what do we produce? Pause the video and try the quiz. Okay, the formula for hydrogen, because it's diatomic, is H2. We use a metal and an acid to make hydrogen, so that's hydrochloric acid and magnesium, or you could use zinc. We collect hydrogen by upward delivery. We test for hydrogen using a lit splint and we get a squeaky pop. Hydrogen can be used in rocket fuel, it's used now as a clean fuel, and in making margarine. And when we burn hydrogen, we produce water. So today we're going to move on, and lesson 4 we are going to look at our final gas, which is carbon dioxide. We're going to look at some uses of carbon dioxide, and we are going to prepare and test for carbon dioxide. Here is a slide showing 3 uses of carbon dioxide. Can you pause the video and see, can you work out what the uses are? The first use of carbon dioxide is it is used in fire extinguishers because it doesn't support combustion. It is also used in carbonated drinks. It is the fizz in Coca-Cola. And carbon dioxide sublimes from a solid to a gas, so it is used as dry ice. It is also a colourless and odourless gas. Today we are going to use another acid reaction to make a gas. This time we are going to use an acid and a carbonate to produce a salt, water and carbon dioxide. You will need to write that equation into your notes. If you have a look at your apparatus, you can see this time the delivery tube is pointing down. So we're collecting carbon dioxide by downward delivery, and we're bubbling it into a test tube of lime water. There is a video clip associated with the preparation of carbon dioxide in your classwork section today. If you have a look at the end of the video, you can see the before and after observations with lime water. At the beginning of the reaction, you can see that the lime water is colourless, and when we produce the carbon dioxide, you can see that the lime water turns milky. That means the test for carbon dioxide is you bubble it into lime water and it turns from colourless to milky. Here is a diagram of the apparatus used for downward delivery. Don't forget to label it. This is page 11 on your gases booklet, can you write in the equation, draw the diagram for downward delivery with a pencil and a ruler, and write in the test for carbon dioxide. There are also some questions on page 12 that you have to complete on carbon dioxide. Our homework today is on a file page to draw the following table and summarise the 3 gases we have met so far. Thinking about their properties, so do they have a colour? Are they colourless? Do they have an odour? Think about their uses. Think of the chemicals we used to make them in the lab and how we tested for these 3 gases.